Hi everyone, welcome back to another video. In today's lesson, we'll go through three more questions from the 2024 Primary 6 WA1 paper from Methodist Girls School. Specifically, we'll be going through question 6, 10 and 11. As per usual, if you want to try out these questions for yourself, it is listed in the description down below. And as per usual, I do not own any of these papers. These are readily available on the internet. So let's start off with question number 6. In this question, a student named Anne painted leaf X, Y, and Z as shown below. Leaf Z is painted on the top and bottom part with black paint, whereas leaf X is painted with oil on the top part only, and leaf Y is painted with oil on the top and bottom. And then remove the leaves and drop an equal amount of iodine on each leaf. On which leaves or leaf would turn iodine dark blue? So before we go on any further, we need to ask ourselves, what is this question really asking? In order for iodine to turn dark blue, it needs to react with starch. And starch is a product of photosynthesis. In the process of photosynthesis, your products would be starch and oxygen. In order for photosynthesis to occur, you will need carbon dioxide, which enters the leaf via the stomata on the underside of the leaf, and you will also need light energy, which interacts with the chlorophyll on the top part of the leaf. That is what the question is really asking. So, as such, let's take a look at individual leaves and see if the leaf can produce starch or can complete the process of photosynthesis. Let's first look at leaf Z. The top and bottom part is painted with a black paint. Not only does black paint interfere with the gas exchange on the underside of the leaf, but black paint also absorbs all light. This would mean that leaf Z will not get any light, and without any light, the process of photosynthesis would not occur. If the process of photosynthesis does not occur, the leaf will not contain starch. Next, let's move on to leaf X. Leaf X is painted on the top part with oil. As we've mentioned earlier, the leaf would need light energy to interact with the chlorophyll on the top side of the leaf, and the leaf would require the taking in of carbon dioxide via the stomata from the underside of the leaf. For some of you who might know, oil interferes with gas exchange. Seeing how leaf X is painted with oil on the top part of the leaf, it would not affect the gas exchange. And thankfully, light energy is still being able to pass through the oil, and light energy can interact with the chlorophyll on the top side of the leaf. Since there is nothing covering the bottom part for leaf X, the leaf can still take in carbon dioxide via the stomata on the underside of the leaf. And as such, leaf X is able to photosynthesize and produce starch, which in turn will turn the iodine dark blue. Last but not least, let's take a look at leaf Y. The top and bottom part of the leaf is painted with oil, while the top part of leaf Y is able to take in light energy. The bottom part of leaf Y is unable to take in carbon dioxide via the stomata because the oil interferes with the gas exchange. Oil prevents any gas from passing through. Therefore, leaf Y would not be able to photosynthesize and in turn would not produce starch. As such, the only leaf here that is able to turn iodine dark blue is leaf X. So here is a summary of what I have covered so far. As mentioned earlier, leaves only turn dark blue when there is a presence of starch. Starch is a product of photosynthesis alongside with oxygen. And then I list down the individual conditions for leaf Z, X, and Y. As you can see, leaf X is the only one that is able to photosynthesize and in turn turn the starch dark blue. So your only answer or only viable answer here is option number 1. Next, let's move on to question number 10. I really love this question because it is one that stumped me as well as I was not paying attention. So this question depicts a child or a student swinging on the swing from position A to B. The question then asks, what is the conversion for the gravitational potential energy and kinetic energy? So before we go on any further, as per usual, let's go through what this question is really asking. This question is asking about the relationship between gravitational potential energy and kinetic energy. Immediately we know option 3 and 4 is out because gravitational potential energy and kinetic energy work together hand in hand. One does not need to stop before the other one starts. So option 3 and 4 are definitely out. For option 1 and 2, the only difference is that for the gravitational potential energy is 0 for option number 2. Before we go on any further, I'll go through what I have covered so far. So as mentioned, I really love this question because it makes you pay attention and think through your options. Option 3 and 4 are immediately out because kinetic energy and gravitational potential energy work hand in hand. Only options left are 1 and 2, where option 2 states that gravitational potential energy is at 0. Before we go on any further, let's take a quick look at gravitational potential energy. So for gravitational potential energy, it requires three things. The mass of the object, which in this case is the student on the swing. Next is gravitational field strength, which is 10 meters per second squared for primary 6 students. Last but not least is also height, which is measured from the ground. Gravitational potential energy increases as height increases, which is something that you need to take note, especially for this question. So when we go back to this question, you realize that gravitational potential energy at any point of the swing is never 0 because the student is never touching the ground at any point during swinging. Therefore, your gravitational potential energy cannot be 0. That means your only option left is option number 1. As a recap, remember that for gravitational potential energy is mass times gravitational force times height. And that is why option number 1 is your answer. Next, let's move on to question number 11. This is a simple short answer question with multiple parts. A student named Yirong set up an experiment to find out how the amount of pollutants will affect rate of photosynthesis. As you can see, the setup here is the hydrilla plant and in pond water from various ponds W, X, Y, and Z. And there is also a light source. As you can see, the outcome of the experiment is listed on the right hand side of the picture. The number of bubbles per minute is highest for the pond for the plant in pond X, and the number of bubbles per minute is lowest in the plant from pond W. So before we go on any further, let's see what this question is really asking. So this question is asking how pollutants will affect rate of photosynthesis. As mentioned earlier, rate of photosynthesis or photosynthesis for that matter requires a light source and carbon dioxide. For carbon dioxide, in this case, is dissolved carbon dioxide from the pond water because this is a water plant in the form of hydrilla, whereas the light source is from the lamp itself. As how some of you might have guessed, if the plant or if the water actually contains more pollutants, lesser light will reach the plant. So the more polluted the water is, less light will reach the plant, and this in turn will result in a lower rate of photosynthesis. A lower rate of photosynthesis would mean that the number of bubbles per minute will also decrease because, as mentioned earlier, your products for photosynthesis is starch and oxygen. Oxygen is the content of the bubbles you see in this experiment. So that is the answer for part A, where they ask what do the bubbles contain. In this case, it is oxygen. The second part of this question asks which is the least polluted to the most polluted pond for all four you see here. As mentioned earlier, we talked about how pollutants affect the rate of photosynthesis. The more polluted the water is, less light will reach the plant. If less light reaches the plant, that means that your rate of photosynthesis also slows down. A slower rate of photosynthesis would mean lesser number of bubbles per minute as it contains oxygen, which is the product of photosynthesis. So from that, we can figure out which pond is most polluted and which pond is the least polluted. The highest number of bubbles per minute is the plant from pond X. That would mean that for pond X, it is the least polluted. The one that has the least number of bubbles per minute is the plant from pond W. That would mean that it is the most polluted. And then from there, you can figure out where you can plug in pond Y and pond Z as well. So here's a recap of what I talked about. More pollutants means that lesser light reaches the plant. Lesser light means slower rate of photosynthesis. Slower rate of photosynthesis means slower or lesser number of bubbles per minute. And from that logic, we can plug in the values for the table listed here. The least polluted, as mentioned earlier, is the plant from pond X, or actually the least polluted is actually pond X itself, and the most polluted is the water from pond W, and you can plug in Z and Y respectively. Next, for part C, the question asks, how does the amount of pollutants in the pond water affect the rate of photosynthesis? Again, we have already covered this earlier. So, more pollutants means that lesser light from the light source will reach the plant. Lesser light means slower rate of photosynthesis. Slower rate of photosynthesis means lesser number of bubbles per minute. Take your time and digest this concept because it is very important for this question specifically. So for question C or part C, It is what I mentioned earlier, and here is the model answer itself. As the amount of pollutants in the pond water increases, the rate of photosynthesis decreases because water allows lesser light to pass through, so that the plant or the leaves of the plant itself trap lesser light to carry out photosynthesis and in turn produce lesser bubbles. The main reason why there are brackets in there in the answer itself is you can interchange the values. If you were to decrease the number of pollutants in the water, obviously in the end you would produce more bubbles. Okay. Last but not least, suggest a control setup for the above experiment is the question or part of the question for 11D. For those of you who have been paying attention, for every science experiment, for it to be a fair test, there should only be one variable. So for this experiment, the only variable here is the pond water. Everything else needs to stay the same. For example, the amount of light, the distance between the light and the plant setup, and even the type of plant itself. The variable here is the pond water. So for the control setup, you need to use a type of water that is not polluted at all. And this is commonly what you refer to as tap water. Because as you might know, when you turn on your tap, especially here in Singapore, it is very clean and free of most pollutants. So here's a recap of what I talked about for 11D. Every experiment has a variable. Variable means something in the experiment that we change for each setup. For this experiment itself, the pond water, polluted pond water, is the variable. So for a control, we need to use one that is not polluted at all. And one can infer or can decide to use tap water, because tap water is one that is least polluted when compared to all these pond water. So the model answer here for 11D is a similar setup with tap water. Okay. So that's it. That's everything you need to know for these three questions. I hope you understand the concepts behind the questions listed here. I wish you all the best for your examination and I shall see you in the next video.